Hello, I'm Ed Murphy with the Astronomy Department at the University of Virginia, and this is Astronomy 1210, Introduction to the Sky and Solar System, Lecture 33, Exploration of Mars. Mars is by far the best explored planet in the solar system, and I thought it would be worth spending some time talking about some of the highlights of that exploration of the red planet, and then at the very end talk a little bit about future missions. So the first thing is that the very first successful mission to Mars was Mariner 4. It was launched on November 28, 1964 on an Agena rocket. It flew by Mars on July 14, 1965, and it returned a total of 22 images of Mars. It seems like an awful lot of trouble to go to just to get 22 images back. And in those days, the imaging cameras did not nearly have the resolution or the ability to take fine pictures that we have today. But on the left is a diagram of what the Mariner 4 spacecraft looked like, and on the right is one of the 22 images that were returned. Although the images were low resolution, certainly by modern standards, the one thing that we can see are impact craters on the surface. Mariner 4 determined conclusively that there are no canals on Mars. There is no evidence for plant life on the surface of Mars, and the atmosphere is very thin on Mars. And like the moon, it is a heavily cratered world. It is a cold, nearly airless, heavily cratered world. Well, the results of Mariner 4 just prompted more missions to Mars. Two of the most ambitious missions to Mars were the Viking 1 and Viking 2 missions to Mars in 1975. So these two missions were proposed in honor of the United States bicentennial. So the goal was that the spacecraft would launch in 1975, get to Mars in 1976, and one of the spacecraft would land on Mars on July 4th, 1976, in honor of the bicentennial of the United States. In the end, when they got to Mars, they discovered that the proposed landing site looked a little too rough from orbit, so they had to spend a few more weeks orbiting Mars, taking photographs of the surface before they found a place that they thought was safe enough to set down. Both Viking 1 and Viking 2 included an orbiter that would remain in orbit around Mars, photographing the surface, and a lander that would land down on the surface. Both orbiters and landers spent a few years, the orbiter spent a few years fully mapping Mars with high-resolution cameras, and both landers succeeded in softly landing on Mars and surviving for a long period of time. The goal for the landers were to investigate the surface properties of Mars, the chemistry of the rocks, the atmosphere. They even carried a number of experiments to search for life on Mars, current life on Mars. This is what the landers looked like. They were not rovers. They did not move around. They set down on the surface of Mars, and they had a weather mast. They had an antenna for communicating with Earth. They had a number of scientific instruments. And this long arm that you see here is a scoop that was used to scoop up some of the soil and bring it into the spacecraft for future analysis. I love this photograph that was taken by one of the Viking landers on the surface of Mars. It shows you frost on the surface of Mars. It gets so cold at night on Mars in the wintertime that the atmosphere can actually freeze out. And the frost that you see here, sort of in between the rocks, that white-colored frost, that is not frozen water. That's actually frozen carbon dioxide. We would call it dry ice here on Earth. It got so cold that night on Mars that the carbon dioxide atmosphere froze out on the surface. Now, Viking 1 and Viking 2 are most famous for including 4 experiments to search for life on Mars. I already pointed out that arm. That arm would reach out and it would scoop soil off the surface. This thing you see over here, that is a covering that was on one of the scientific instruments. So that's why that cover is sitting there on the surface of Mars. But the scoop, the arm could reach out and it could scoop down onto the surface and it could bring those samples back into the spacecraft and do experiments on them. And the spacecraft scooped up some soil, and the experiments were a mass spectrometer. A mass spectrometer simply breaks the soil down into its basic molecules, and it looks for evidence of organic compounds. And no organic compounds were found at either of the 2 landing sites. And then they had 3 additional experiments that searched for metabolic activity, right? All living things do sort of some of the same things. They respirate, which is that they take gases out of their surrounding bring them inside the organism and process those gases and release waste products. They bring in water from their environment, use the water to live, release that as waste products. And they take in nutrients from their environment, utilize those, and release waste products. So the 3 experiments were to test exactly those things: respiration, use of water, and use of nutrients. So they would tag nutrients with little radioactive tracers, or tag water with radioactive tracers, and feed that to the soil to see if the soil would result in the waste products that living organisms would give off. What they hadn't expected on Mars is that the chemistry of the soil on Mars is extremely unusual, and some of the experiments gave positive results. But in hindsight, looking back at those positive results, it's pretty clear now that what was going on was that the soil on Mars contained perchlorates. And these perchlorates reacted with the water that was fed to them to release oxygen. And so it is likely that what we were seeing was a chemical reaction and not the result of life on Mars. Nevertheless, there are still scientists who hold out for the fact that because multiple experiments gave evidence that there was life in the soil on Mars, that life on Mars does exist. We will know more with the launch of the Perseverance rover later this year and future spacecraft that go to Mars. Now that we know about the chemistry of the soil on Mars, we can design new experiments to get around that, to look for life on the red planet. But the most important thing that the Viking orbiters showed up from an orbit around Mars was evidence of past water on Mars. Viking was the first mission to clearly show channels that had been cut by liquid water in the past. And as I said in the last lecture, that raises some interesting questions. How long did the water flow? Where did it flow to? Did it pool on the surface long enough that life could develop? Where did all that water go? And if the water did pool for long periods of time, did life ever develop on Mars? And if so, is there still life today? And as examples of what some of the spacecraft are doing, right now we have, the Mars Global Surveyor is no longer talking to us, so it is dead, but we have the Odyssey mission and the Mars Reconnaissance Orbiter in orbit around Mars, returning high-resolution images of the surface, and that helps us to better define the geology of the planet, find locations where we can send future landers, and find locations where water may have flowed in the past. We also have spacecraft in orbit around Mars that are studying the Martian atmosphere today. The United States, NASA, has a mission called MAVEN, the Mars Atmosphere and Volatile Evolution Mission, which is trying to understand where did all the water on Mars go and what happened so that Mars today has a thin atmosphere that can't support liquid water on the surface when the evidence is clear that there used to be liquid water on the surface, which meant that the atmosphere would have had to have been much thicker. So let's look at some of that evidence for past liquid water on Mars. The primary evidence comes in the form of channels that were clearly cut by running water. Here's an example of a canyon system that looks very much like canyons on Earth that were cut by running water. Here's another example of a canyon system. On the left, we see the canyon as seen by the Viking spacecraft. On the right here, we see the canyon, same canyon, this little piece of it right here, in fact, as seen by the Mars Global Surveyor spacecraft. And the important thing to see is this is clearly a canyon that was cut by running water. And in fact, in one place here, we can actually see the old dry riverbed down at the bottom of the canyon. This little feature right there is the old dry riverbed. And in fact, some of the missions have shown evidence that there might be liquid water flowing on Mars today. On some steeper slopes on Mars, not all, but some steeper slopes, there is seasonal evidence that something is dripping out of the rocks and possibly flowing down the surface, flowing down here. And then in some cases, it even appears that it is pooling in the bottom of the craters or at the bottoms of these slopes. Now, what's amazing about the orbiters that we have in orbit around Mars today, this is a large crater on Mars. So we're looking at the top of the wall right here. And we see these dark features. And it looks like something is seeping out of the rocks here, just sort of dripping down. Here are close-up images of that. And this is amazing. That's 100 meters or 110 yards across. And so we are seeing rocks on the surface of Mars that are about the size of a person from our orbiters in orbit. In some of these cases, not all, but in some of these cases, we believe that what we might be seeing here is very briny water, water that is trapped underground, that when the season is right, when during high summer, when the sunlight is striking these walls, it warms them up to the point that the water is liquid enough, that it is warm enough that it can actually drip down. And it doesn't freeze immediately because all that salt in the water, that's what makes it briny, keeps its freezing point, keeps it above the freezing point so that it can flow for a while before it finally cools off and freezes. Now, by far the most famous exploration from the last few decades of Mars are the rovers that we have sent to Mars. They are certainly the ones that best capture the public's attention. We've launched a total of 4 rovers to Mars. The 2 most productive ones to date, well, I shouldn't say that because Curiosity's been very productive, but 2 of the more productive ones were Spirit and Opportunity. Spirit was launched in 2003. They were both launched, Spirit and Opportunity were both launched in the same summer of 2003. They landed in January of 2004. Spirit operated from January of 2004 to March 2010, so it operated over 6 years on the surface. And Opportunity lasted from 2004 to June of 2018. It lasted 14 years on the surface. And that's amazing, because these little machines were only designed to last 90 days on the surface of Mars. A nominal mission, what would have been called a successful mission, was if they lasted 90 days. And instead, they lasted 6 years and 14 years for Spirit and Opportunity, respectively. The goal for these rovers were to look for evidence of liquid water on the surface of the planet. Our orbiting spacecraft had returned evidence, at least from orbit, that looked like there were places on Mars that had once had liquid water on the surface. The goal with the Spirit and Opportunity rovers now was to get down on the surface and confirm those results. So, what kind of scientific instruments do they have on board? Well, they both had panoramic cameras so that they could take spectacular images of their surroundings. They had infrared spectrometers that would allow them to measure the mineralogy of the surface rocks. That is, just by taking an infrared photograph of the rocks and by looking at how the different wavelengths or different colors of infrared light are reflected from the rocks, they could get a very crude reading on the type of rock they were looking at. Then specifically to measure the amount of elements and the amount of iron in each rock, there were X-ray and gamma-ray spectrometers. These are devices where the rover could go right up to the rock and they could put the spectrometers on the surface of the rock. And in the case of these, they would bombard the rock with X-rays and gamma rays, and then as they scattered back, they could use those to determine both the mineral composition of the rock and determine the iron content of the rock. And then finally, there was a RAT on board, a rock abrasion tool and a microscope. That was literally a little grinder that could grind into the rock to show you a nice pristine face of the rock. Most rocks sitting on the surface of Mars have been weathering in place for millions of years, and they're so weathered that you can't get a good look at what the crystals in the rock look like. So the rock abrasion tool would actually grind down through the rock and get a nice pristine surface that could be photographed with a microscope to examine the minerals in the rock. Spirit and Opportunity landed on 2 opposite sides of the planet. Spirit landed in a giant crater called Gusev Crater, and Opportunity landed in a flatter area called Meridiani Planum. And you'll notice that both of them are on this boundary between the southern highlands and the northern lowlands. As I mentioned, the southern highlands, the boundary between the southern highlands and the northern lowlands are where we see lots of evidence that water had once flowed on the surface of Mars. And for that reason, a lot of the missions that we're targeting to Mars right now that are interested in this question of water are searching these areas. So, here is the landing site for Spirit. It's a giant crater that's a little bit less than 100 miles across. And the goal for looking at this crater, it has a very flat bottom on it. And there is what looks to be a channel here where water may have flowed into or out of the crater. And so this was a perfect place for Spirit to go look. It looked like this crater may actually be filled with sediments, and that those sediments may be left over from a lake that had existed here for a long period of time. Complicating the matter in this case is it also turns out that there were lava flows in this area. And so it's wasn't clear before launch whether Spirit would find evidence for lake sediments that water had pooled here for long periods of time or evidence for lava flows. it turns out that it found lots of evidence for lava flows, but did find some evidence for liquid water. So here is one of the first images that Spirit took after landing on the surface of Mars. I think as you watch through these next couple slides, it's really just quite remarkable, the images that we've been able to return from the surface of Mars. In many cases, I like to point out they're better than the pictures that I take when I'm on vacation. Off in the distance, it's at the Spirit landing site, they could see these hills. These are called the Columbia Hills. They're in honor of the Columbia astronauts that were killed in the space shuttle in 2003 when it burned up on re-entry. This tallest mountain at the center right here is called Husband Hill in honor of Rick Husband, who was the commander of the space shuttle Columbia. Down below are the same hills. This is how it would appear on the top to you and me standing on the surface of Mars. On the bottom is an image that shows you what happens when you use different colors of light, including infrared light. You can see that the rocks reflect light in different ways, and that tells you about their composition. So just with a quick photograph like this, you can not only get the lay of the land, but you can determine where the different rock types are and where you can best do your exploration. Well, after landing on the surface, Spirit was designed to last 90 days, only going to last 90 days. Initially, there didn't seem to be any chance that they would get to drive off and examine these hills here because the hills were much too far away. They were a few miles away. But after 90 days, Spirit had explored its local area and it was still doing quite well, so the scientists decided to drive towards the mountains. Now, the mountains were far enough away that it was going to take long enough to get there, that there didn't seem to be any chance that the robot would make it to the hills, but it was at least worth trying to see what was over in this direction. And so over the course of more than a year, they drove across the surface towards Husband Hill, and after a year of driving, they got to the base of Husband Hill. The rover was still operating fine, so at that point they decided to drive up the slope of Husband Hill, and Spirit made it all the way to the top of Husband Hill. And this is an image from the top, from the summit of Husband Hill. Well, after this, it went down the other side of Husband Hill, so it went down the backside of Husband Hill. These are an image that shows you sort of the driving distances. So here it is where it landed. There it was after 50 days. And then after day 100, a sol is a day on Mars. So that's a little bit longer than a day on Earth. But these are driving days on Mars. There is after 125 days, after 150 days on Mars. Spent a long time here exploring the base of the hills. And then got here sort of after 1 year on Mars, got here right to the bottom of the hill and took almost another year to climb up to the top of Husband Hill and then back down the other side. Once it was back down on the other side, unfortunately, Spirit got stuck in the sand on the other side. Over the years of driving on the surface of Mars, it had a number of wheels that were no longer operating well. It got into some soft sand, and Spirit dug itself into the sand, unfortunately, and couldn't get out. But worse yet, it was tilted in such a way that its solar cells were not well pointed to the sun when winter came. Mars goes through seasons just like the Earth does. The sun is very high in the summertime, and it's very low in the wintertime. Well, the solar arrays were pointed in such a way that when wintertime came and the sun got low in the sky, they were not able to recharge the batteries on the rover, and the rover died. So that is Spirit. One of the discoveries that the rovers made are dust devils on Mars. These had been suspected before, but they got beautiful movies showing the dust devils. You can even see the streak that it leaves on the surface over there after it goes through and it clears some of the dust away and shows some of the darker colored land that's located underneath the dust. Turns out these dust devils would occasionally pass right over the rovers themselves. The wind is not strong enough in any way to damage the rovers or to hurt the rovers, but it actually did do them a favor. Over time, Martian dust would build up on the surface of the rovers, and that dust would actually cut down on the power that the solar cells were generating. So a couple times in the history of Spirit and Curiosity, dust devils actually passed right over the spacecraft and blew off some of that dust. Now, Opportunity landed in a different location. These colors are from orbiting spacecraft looking at Mars, and this yellowish red color indicates the presence of hematite. Hematite is a type of iron-based mineral that often forms in the presence of water. So this photographic evidence from space indicated that this part of Mars had a lot of hematite on it. And as I said, hematite forms in the presence of Mars, so possibly water existed here for a long period of time. Opportunity was the best example, and probably in the solar system, of a hole-in-one. After getting all the way to Mars, it actually landed inside of a small crater. So the first thing it was able to do was roll off its landing pad and roll over and look at some of the rocks in the rim of a crater. The beautiful thing about craters on the surface of other planets is they act as natural excavators. You'll remember from the lecture on lunar geology that scientists are interested in looking at layers because the layers can tell you about the history of a planet. Well, the rovers are not large enough to have shovels that could allow them to dig down through significant layers of Martian soil. But craters have already done that. And this crater was a beautiful example that as soon as Opportunity drove off of its landing pad, it could go over and investigate the rocks in the wall of this crater. And you can even see that the rocks are layered. Now, at the landing site, Opportunity discovered millions upon millions of these little blue pebbles on the ground. These little blue pebbles were called blueberries. Here's a close-up taken with the microscope of what one of them looked like. These blueberries are actually little nodules of hematite. This is where the hematite signature is coming from. And these things formed as concretions in the rocks when they were saturated with water. That is, at some point, these rocks were saturated with water and the hematite came out of solution and condensed to form these little hard nodules. And then, as these rocks were worn away by erosion over time, the hematite nodules, the little hematite balls, are much, much denser. They're much tougher than the surrounding rock. And so as the rock weathered and eroded away, these things were left behind. Another fascinating discovery was sedimentary rocks. When you look at these rocks, you can clearly see laminar or flat layers of rows. And in fact, one of the more spectacular discoveries was this series of rocks right here, where you'll notice the layers are curved and rippled. And then the layers get very straight, and then they get curved and rippled again. And these layers were laid down by sediments in a lake that existed on this part of Mars for a long period of time. And what we're seeing here is the sediments getting laid down. And when the units are rippled like this, it means the sand was rippled, and it's usually rippled when the water is shallow. And you have wave action acting on the surface. It can leave ripples in the sediments laid below. The middle unit here, which is stratified and planar, is when the water got deeper. And at this point, it was no longer subject to those ripples that you would find on the surface. And so the sediments are laid down much more uniformly and much flatter. But then the water got shallow again and the unit became rippled again. So this is a beautiful example of water appearing on Mars, getting very shallow, getting deeper and deeper and deeper till the water was deep enough that the units are no longer rippled, and then the water started evaporating and getting shallower and shallower. All right. Opportunity had a tremendous life on the surface of Mars, operating for 14 years. It explored a number of craters on the surface. It landed in Eagle Crater, it explored Endurance Crater, and then it drove all the way down here after almost 3 years on the surface of Mars to get to Victoria Crater. Victoria Crater is about 2,500 feet across, or about half a mile in diameter. Here is what the rim of the crater looks like. Here's another beautiful view of the rim of the crater. Opportunity would actually drive out here to get good views down into the crater. There were all these beautiful layers in the rocks, and the geologists could use photographs like this to look at the layers, to see how these, you can look in these rocks down here and see all these beautiful layers just laid out, so geologists could understand how these rocks were put in place. What was most amazing about Opportunity's time at Victoria Crater was that it was actually photographed by some of the orbiters. You can actually see here on Cape Verde right here, this little rock cliff. This is Cape Verde right here. And on this photograph, I think Cape Verde is this one right here. But Cape Verde is just this rock formation that is jutting out. Opportunity drove out to the edge of Cape Verde, or not right to the edge, but onto Cape Verde. But here's a photograph taken by one of the orbiters where you can actually see Opportunity sitting on the surface. You can even see the tracks it made as it drove across the surface, took a look into the crater, came back out, went around over to Cape Verde right there. This is a great image where you can not only see the rover, but you can actually see the mast sticking up, and you can see the shadow of the mast down on the ground right there. Isn't that amazing that we can actually photograph the rovers from in orbit around Mars? After Victoria Crater, it drove on down to Giant Endeavour Crater, which is about 22 kilometers or 14 miles in diameter. It drove up, it drove around Cape York here, and then there was lots of evidence for clay-like minerals. Clay is something that also only forms in the presence of water, and so there were lots of evidence of clay-like minerals on top of these rocks up here on the rim of Endeavour Crater. And so the goal was to examine Spirit Point and then drive up the mountain to the top here of the rim. As the rover came in here and was parked down here, it took this absolutely spectacular image. These hills in the distance are actually the rim of Endeavour Crater right there. So what you're looking at is standing here on Mars, looking at these mountains that form the rim of the crater. Just really spectacular. Eventually, it not only circumnavigated and drove around Cape York, but it came and it drove up onto the top of the rim up here, made it to Cape Tribulation. And then, unfortunately, not long after being up on top of Cape Tribulation and looking out over the giant Endeavour Crater, you can look at how dusty the solar cells are down here. But here we are on top of the rim of that crater, looking out over the bottom of the crater to the distant rim, 22 kilometers off in the distance out there. And like I said, you can see all the dust on the solar arrays down here. Unfortunately, in the summer of 2018, a giant dust storm encircled Mars. And during that dust storm, it got so dark at Opportunity's landing site that not enough sunlight made it down to the solar rays to power the spacecraft. And Opportunity lost power and froze, or something inside the electronics broke. And when the dust storm lifted and solar energy could again get down to the spacecraft, it never called home. It never responded. So to give you an idea of what the rovers look like compared to human beings, these are the the three types of rovers that we've sent to Mars. We sent Mars Pathfinder back in 1996 just to practice driving a rover on the surface of Mars. Spirit and Opportunity were identical. They looked like this. And then this is the Mars Curiosity rover that is on Mars right now. And the Mars Perseverance rover that we're sending to Mars in July of 2020 looks very similar to this. I thought now would be a good time to break away for a moment and show you how it is that the rovers get to Mars. And so I'm going to show you two quick videos. The first video here is going to show you what it takes to get to Mars. So this is the actual launch of one of the rovers to Mars. This is what the launch of Spirit and Opportunity looked like. There's no narration to this, just some sound effects. But think back to our lecture on what it takes to get into orbit around the Earth. Remember that you spend most of your time accelerating sideways as opposed to accelerating upwards. And you will see in this video, you'll hear them announce roll program as the rocket, I should say, starts to roll over, and then later on you will see it accelerating. You will see that it is rolled over on its side, accelerating sideways to get into orbit around the Earth. Now this one was actually going fast enough that it didn't spend long in orbit around the Earth. It fired a third stage to take it onto Mars immediately. Other things you'll notice is that with rockets, there's a tremendous amount of waste. When we are done with a booster, that booster separates from the rocket and it typically falls back to Earth and ends up crashing down into the oceans. So you'll see a lot of that during this video. But this is how Spirit and Opportunity got to Mars.
SSC disconnect enable on.
35. Let guys go. Hydraulics go.
Pressurized vehicle locks tank.
Pressurizing.
SSC hydraulic pump control on.
On.
CLCDR pad B deck flush on.
On.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, engine ignition, and liftoff of the Delta II rocket with the Mars Exploration Rover.
The program response is good.
And that is how you leave the Earth and head to Mars. Now, once you get to Mars, there are a couple different ways to land. It turns out that both Spirit and Opportunity landed using airbags. That is, they inflated giant airbags and they bounced down to the surface. But I wanted to show you instead how it is that the Mars Science Laboratory, that is the Curiosity rover, landed on the surface of Mars. And I wanted to show this because the Perseverance rover is going to land in almost the same way, in substantially the same way, I should say. So here is how Mars Curiosity got down to the surface.
When people look at it, it looks crazy. That's a very natural thing. Sometimes when we look at it, it looks crazy. It is the result of reasoned engineering thought, but it still looks crazy. To the top of the atmosphere, down to the surface, it takes us 7 minutes. It takes 14 minutes or so for the signal from the spacecraft to make it to Earth. That's how far Mars is away from us. So when we first get word that we've touched the top of the atmosphere, the vehicle has been alive or dead on the surface for at least 7 minutes.
Entry, descent, and landing, also known as EDL, is referred to as the 7 minutes of terror because we've got literally 7 minutes to get from the top of the atmosphere to the surface of Mars, going from 13,000 miles an hour to 0 in perfect sequence, perfect choreography, perfect timing, and the computer has to do it all by itself with no help from the ground. If any one thing doesn't work just right, it's game over.
We slam into the atmosphere and develop so much aerodynamic drag. Our heat shield, it heats up and it glows like the surface of the sun. 1,600 degrees.
During entry, the vehicle is not only slowing down violently through the atmosphere, but also we are guiding it like an airplane to be able to land in a very narrow, constrained space. This is one of the biggest challenges that we're facing, and one that we had never attempted on Mars.
Mars is actually really hard to slow down because it has just enough atmosphere that you have to deal with it. Otherwise, it will destroy your spacecraft. On the other hand, it doesn't have enough atmosphere to finish the job. We're still going about 1,000 miles an hour. So at that point, we use a parachute.
The parachute is the largest and strongest supersonic parachute that we've ever built to date. It has to be able to withstand 65,000 pounds of force, even though the parachute itself only weighs about 100 pounds.
When it opens up that fast, it's a neck-snapping 9 Gs.
At that point, we have to get that heat shield off. It's like a big lens cap blocking our view of the ground to the radar. The radar has to take just the right altitude and velocity measurements at just the right time, or the rest of the landing sequence won't work.
This big, huge parachute that we've got, it'll only slow us down to about 200 miles an hour. And that's not slow enough to land. So we have no choice, but we've got to cut it off and then come down in rockets. Once we turn those rocket motors on, if we don't do something, we're just going to smack right back into the parachute. So the first thing we do is make this really radical divert maneuver. We fly off to the side.
Diverting away from the parachute, killing our horizontal velocity and our vertical velocity, getting the rover moving straight up and down so it can look at the surface with its radar and see where we're going to land. And we head straight down to the bottom of a crater, right beside a 6-kilometer high mountain.
We can't get those rocket engines too close to the ground, because if we were to descend propulsively with our engines all the way to the ground, we would essentially create this massive dust cloud. That dust cloud could then go and land on the rover. It could damage mechanisms and it could damage instruments. So the way we solve that problem is by using the skycrane maneuver.
20 meters above the surface, we have to lower the rover below us on a tether that's 21 feet long, and then gently deposit it on its wheels on the surface.
As the rover touches down and is now on the ground, the descent stage is in a collision course with the rover. We must cut the bridle immediately and fly the descent stage to a safe distance from the rover.
I think what's most amazing about the Mars Curiosity rover is that landing was successful. As complicated as that is, all of the things that had to go right, they all went exactly right, and that rover set down perfectly on the surface. Not only that, as it was parachuting down through the atmosphere, one of the orbiting spacecraft happened to be flying overhead. The landing was timed in such a way that spacecraft could be monitoring what was going on with the lander, but it also used its camera to snap this photograph, which I think should go down as one of the greatest photographs ever taken in the history of space exploration. Here we see Curiosity floating underneath its giant parachute as it floats down to the surface, as taken by the spacecraft orbiting overhead. So the Mars Science Laboratory Curiosity, as it's called, is so far the strongest, or the most powerful, most capable rover that we have ever launched to Mars. It has an amazing suite of scientific instruments, and again, its goal was to look for evidence of past water on Mars. One of the more interesting scientific instruments it brought along was a giant laser with an infrared camera system, so that you could actually zap a rock with the laser and vaporize some of the rock. And then the infrared light that is transmitted, that transmits through that vapor, allows you to measure the composition of the rock without actually having to go up and drill into the rock and sample it. But nevertheless, there would be times when the rock was interesting enough that you would want to drill into it. And on the robotic arm that the rover carries, it has a drill assembly that allows them to drill into the rock. They can take photographs of the drill site. They can also take rock samples out and deposit them into experiments that are located inside the rover. And these experiments allow you to pass X-rays through the rock to determine the structure of the minerals inside the rock, and other experiments as well. There's also a weather station on board. There's the antenna that it uses to contact Earth. There's a nuclear reactor. The Spirit and Opportunity were powered by solar power, but Curiosity is powered by a nuclear reactor on the back. So these are just some of the scientific instruments. So there is the nuclear reactor on the back. Chem camera is the one that shoots the laser. The mast cameras here are the high resolution cameras that take the beautiful images. SAM is the sample analysis, and ChemMin. These are two experiments to sample the rocks. So the arm can actually drill out samples and drop them in one of these two experiments. Bring the material inside the spacecraft and analyze it there. A radiation detector on the outside, and then even more scientific instruments on the robotic arm. So the landing site for Curiosity was inside of Gale Crater right here. So that's where Spirit landed, once again on that boundary between the southern highlands and the northern lowlands right there. But what's interesting about Gale Crater is that Gale Crater is a large crater that has a huge mountain, Aeolus Mons, located at the center of it. And it was clear from orbital photographs that Aeolus Mons had lots of layers in it. Now, Aeolus Mons is not the central peak of Gale Crater right here. What's going on is that there was a giant impact billions of years ago on the surface of Mars. And over time, sediments were deposited and laid down in that crater. And then over time, the winds changed and those sediments eroded around that mountain. And so what we have left today is a mountain at the center of the crater. The peak of the mountain is actually taller than the rim of the crater, which is why we know that it's not one of those rebounds that we see on lunar craters, because on lunar craters, the central peak is almost always at the rim of the crater or lower. So this was an indication that what we're seeing here are layers of sediment. And you'll remember from our lecture on stratigraphy, for studying the layers of the moon and the layers of the Earth, that this is exactly what geologists want to do, is study layers. And here are the layers that we see in the rocks at Gale Crater. And keep in mind that each one of these layers records probably millions of years of history of Mars. And from driving to the bottom to the top, we could in fact investigate hundreds of millions, if not billions of years of the history on the surface of Mars. So there's just more pictures of that same scene to give you an idea of how far we're talking. That peak is about 10 miles away from the rover, and the stuff in this valley down here is a couple miles away. So that's just some distances to things. Many of the scientific instruments are located on the arm out here. That is where the drill mechanism is located. Other scientific instruments are located out there. There is also a camera on the arm. And I can imagine that someday when humans go to Mars, they will take their cameras, and as we do here on Earth, they will hold up their camera and they will take a selfie of themselves. Well, it turns out Curiosity did exactly that on Mars. This is a selfie of Curiosity on the surface of Mars. It extended the arm out. The camera on the arm couldn't take a photograph of the whole scene at once, so it had to take many photographs, and they patched them together to make this mosaic image. And as they were doing that, they were able to edit out the arm out of the photograph. So you can see this absolutely beautiful image of Curiosity sitting on the surface of Mars with Mount Sharp there in the background. Aeolus Mons, the big mountain at the center of the crater. Well, here's an example of what ChemCam can do. So that camera where they shoot the laser at the rock, as I said, they analyze it with ultraviolet, visible, and infrared light. And then they can tell exactly what the composition of that rock is from looking at it. They can also have a small scoop on board. They can scoop up small samples of soil, bring those inside the rover, and analyze them as well. Curiosity has discovered lots of evidence that there used to be liquid water on this part of Mars. In fact, in this area, you can see these sedimentary rocks right here are made up of smooth pebbles that are clearly rounded. And rounded pebbles, the way that you make a pebble round, the only way to make it round is having it roll for long distances in flowing water, because that breaks off all the sharp edges here on Earth because of water erosion. Pebbles in rivers are rounded. And so this is evidence of an ancient stream bed on the surface of Mars. And as the rover drove looking at different layers, there's over 1,000 vertical feet of rock that was formed as the sediments, as mud at the bottom of a series of shallow lakes. And it looks like on this part of Mars that it wasn't one shallow lake, that the shallow lake existed and then dried up and then existed again and dried up and existed again. But rivers and lakes persisted on this part of Mars for more than 1 million years. Now, I'm just going to show you some absolutely stunning images that were taken by Curiosity. I love this image. I love the view of the sunset, but I just love that view of the mountains off in the distance. Of course, these aren't the mountains off in the distance. Those are the rim of Gale Crater off there in the distance. Just a couple close-ups of some of these features. So here's a close-up of one of the features. And again, with the crater the crater rim off in the distance, and there's another view right there. Over the last few years, NASA has been building a new rover to go to Mars. It was recently named Perseverance. And so the rover Perseverance is scheduled to be launched in July of 2020 with arrival at Mars in February of 2021. The location, the landing site for Mars 2020 rover is called Jezero Crater. Jezero Crater, when you take a look at it here, it's Jezero Crater right here has a diameter of about 30 miles. So it's about 30 miles across. But what's interesting about Jezero Crater is there is clearly a place where water flowed into the crater. We know that water was flowing in here because we see these sedimentary deposits. We see it's literally like a delta where the sediments from this flowing river were laid down over time. In fact, if you look at the sediments carefully, you can even see the path as the river meandered over long periods of time. It flowed out here and then out here and out over here. So it flowed in different places. Jezero Crater was once filled with water, and we know that because, in fact, the water overflowed this far edge of the crater right here and flowed out through this stream bed down here. So here's a place where water existed on Mars long enough that sediments were laid down and the water actually overtopped and flowed out over there. There's another place here where water flowed into the crater right there. So the goal for Perseverance is to land next to these sediments here and go over and examine these sediments. And the Perseverance rover looks remarkably like the Mars Curiosity rover. It is built on the same platform, although the scientific instruments on board are different. And the reason that the scientific instruments are different is in the case of the Perseverance rover, the focus is on past life on Mars. So the goal for Perseverance is not only to study the geology and not only find the past evidence for liquid water on the surface of Mars and do some of the same things that Curiosity had done, like return stunning photographs from the surface, but it also has a number of scientific instruments that will look for past evidence of life on Mars. So it should launch between July 17th to August 5th, 2020. As I'm recording this launch has been delayed from July 17th until July 30th. That is getting dangerously close to the end of the launch window, which ends in early August. If they don't launch by early August, they may not make it to Mars. The last I had heard is that they are looking at ways that they might be able to extend the launch window for a week or two, just in case they run into any more issues or problems. But in any case, the landing is scheduled for February 18th of 2021. The goal of Perseverance is to identify environments where microbial life might have existed in the past, look for signs of past microbial life, in particular fossilized evidence of past microbial life, but also chemical evidence of past microbial life. It's going to collect soil and rock samples, and it's going to store them for a future mission that will actually go to Mars and retrieve these samples and bring them back to Earth. And it's also going to test oxygen production on Mars. So just very quickly run through some of the scientific instruments. It's going to have mast camera. This is Mast Cam Z, as it's called. It's a very advanced camera that's capable of high definition video and taking very high definition panoramic color photographs of the surface, and also able to take stereo images. The Mars Environment Dynamics Analyzer is, you can think of it as the wind station, the weather station on Perseverance. It's going to measure temperature, wind speed, wind direction, pressure, humidity. It's also going to measure radiation on the surface of Mars so that we can determine what kind of radiation environment astronauts will have to survive on the surface of Mars. MOXIE is a fascinating instrument that we're sending to Mars. It's not going to tell us much about Mars, but what we're going to practice doing is building or creating oxygen on Mars. It's going to demonstrate the ability to take carbon dioxide out of the Martian atmosphere, break it down, and generate oxygen. And this is important because future astronauts, especially human missions to Mars and colonization of Mars, will require exactly these kinds of technologies. And so for the first time, we're going to fly one of these to Mars and actually practice making oxygen on the surface of Mars. The planetary instrument for X-ray lithochemistry is going to measure the chemical composition of the rocks on Mars. So this, in combination with the cameras, will allow us to determine the past history of the geology of this part of Mars, but it will also allow us to detect the chemical signature of signs of past life on Mars. There's a radar imager that's going to allow us to ground penetrating radar that's going to allow us to look underneath the ground, to look at the different layers on this part of Mars, to teach us more about Martian geology, and in particular, to look for water and ice up to 10 meters below the surface. Maybe there is still water trapped underground on the surface of Mars. There will be SHERLOC, which is another great acronym, stands for Scanning Habitable Environments with Raman and Luminescence Organics and Chemicals. It's a fairly complicated instrument that consists of spectrometers, lasers, and a camera, and it's going to be able to detect organic molecules and biosignatures for current life on the surface of Mars and for past life on Mars. And then finally, SuperCam is another one of these laser devices like ChemCam that we saw on Curiosity that's going to be able to zap rocks with a laser and use that to determine the atomic and molecular composition of the rocks. Attached to the bottom of the rover is a whole nother spacecraft, a Mars helicopter. It's a technology demonstrator, so we're not hoping to get too much out of the helicopter, but the hope is that it would fly up to 5 times over a period of 30 days. It's got a small camera on board. It will actually be dropped off the bottom of the rover. The rover will drive away to a safe distance, and then the Mars helicopter will practice flying itself a few times. And then last but not least, is that as the rover drives on the surface and as it finds really interesting samples, it's going to cache those samples. It is bringing a series of sample collection tubes. It will drill those samples, put them in the sample collection tubes, seal the tubes, and every now and then it will land and return back to a cache site. And that cache site is where we are going to send a future rocket to land on Mars, collect those samples, and bring them back to Earth. Although Perseverance will not actually be able to bring those samples back, having them cached like that will make it easier for a future spacecraft to just land there, pick up all the tubes that have been dropped off, and bring all those tubes back to Earth. So, hopefully in the next decade or so, we will see another mission designed to land in this exact same area and bring those samples back. All of this leads to the final question of what is the future of Mars exploration? And the question is, when will humans land on the surface of Mars? Well, I'm afraid I've run out of time in this lecture. I'm not going to get the chance to address it in any detail today. If you would like to know more about what the first human mission to Mars might look like and when it might occur, can I recommend my class, Astronomy 3450 Mission to Mars? In Astronomy 3450, we spend the whole semester looking at the history of spaceflight, the history of the Apollo programs as an example of human exploration of another world, and it all leads us to examine what the first human mission to Mars might look like sometime in probably the 2040s or the 2050s. It's a class designed for non-science majors, so you don't have to, there won't be a lot of algebra in the class, about as much algebra as there has been in this class, but no more math than algebra. But it is a fascinating class where we will study what hopefully you will get to see in your lifetime. So please join me in the next lecture. Now that we have talked about Mars and the exploration of Mars, we're going to skip over the asteroid belt, go out to Jupiter, and we will take a look at the giant planet Jupiter. Take care. See you in the next lecture.